All right. Let's continue from where we stopped. We talked about we had finished converting 37 into binary, and we got this value here. But remember that we have the 0.375. okay, so the 0.375, we said it is going to be a multiplication instead of a division because it is after a point. So when you get 0.375 times 2, you get 0.750. So an integer that you have is 0, and that is why we have 0 there. So get the answer you have here, multiply it by 2 again, you will have 1.500. An integer is what? Is 1. So do this until you get 1. So you have 0.5, which is this, times 2, and it gives us 1.000, and this is an integer is 1. So that means the 0.375 base 10 is equivalent to, when we write going downwards. So when we write going downwards, we shall have a 0, which is this. We shall have a 1 and another 1. So this one is now the 0.375, and therefore we can add it to our number that we got. So that means 37.375 is equivalent to 1 0 0, another 1 0, and 1.011. So this is our binary equivalent. All right, so let's go on, and then we see hexadecimal. Can we convert from hexadecimal to decimal? Yes, the answer is yes. Let's see how we do it. So we have 2AF here, and then we want that 2AF to be in decimal. So how do we do it? We know that hex means 6. All right, x means 6, and then decimal means 10, so that is base 16. So let's multiply by the base. So we have this 2 times 16. All right, we go on, we have a times 16, but we know that a means 10. I think we remember very well from somewhere here that you have a 0 up to 9, and when you reach 10, you now start counting a. All right, so 10 times 16, and then plus 15, which is the f, and when we come here, you will see that f means 15. Okay, so 15 times f. So the powers will run from 0, 1, and then 2. Good. So this is going to give you this, and finally you have this in base 10. So can we also get conversions from decimal to hexadecimal? The answer is yes, but here the trick is going to change. Okay, the trick is going to change. So let's say we have 4 2 3 base 4 423 base 10 and we want to take it to base 16. So you're going to get 4, 2 and 3, divide it by 16 as the base. So when I divide by 16, the answer I get 26, and then the remainder is going to be remainder what? Remainder 7. So this remainder that I have got in the first division is going to be actually the number which will end my hexadecimal number. Okay, so I'll write something, maybe A, B, but at last position I'm going to have 7. Okay, so let's go on. Now you go on and divide this 26, the value you have got. So 26, this 26, when you divide it by 16, you're going to get 1 and remainder 10. Okay, so you divide until you get an answer as 0. All right, so here we are going to get the 1, which was our result, divide it by 16, and then we shall get an answer 0, remainder 1. So whenever you get an answer 0, that means the remainder is going to be the beginning of your hexadecimal value. That means you're going to have something like 1, because this is what we have got here. 1, then some numbers here, and then 7. Okay, because 7 is what we got in the first division, and then 1 is what we got in the last division. Alright, so let us read the results upwards as usual. So when I read, I'm going to I see I'm having a 1, so I'm going to write this 1 as the beginning of my hexadecimal. Then I'm seeing here a 10. Remember, a 10 in hexadecimal means A, so I'm going to write here A. And then lastly I have the 7, and I write 7. So that means that our number, which is 423 base 10, is equivalent to 1A7 in hexadecimal. All right, so we can as well convert hexadecimal to binary, and we just need to only get the values. Okay, we get the values that are there. So for example, you have 9F2 base 16, and we want to take it to binary. So a 9 we know that in binary is equivalent to this. And F, we know that F is equivalent to what? F is equivalent to 15, and 15 in binary is this. Okay, and then 2 in binary is this. All right, so let us concatenate it, which is this, which is also that, and the 2 is this base 2. So basically that is how you can convert from hex to binary. We shall look at binary to hex when we come back.